Greetings and welcome to this webinar on shaders with me, Aaron Craig, and Let's Learn This Together and Yo-Yo Games for GameMaker. I am super excited. If you know nothing about shaders or just a tiny little bit, then this is going to be the perfect place to start. We are going to introduce what shaders are, how they kind of work, the misnomer of the name of shaders, because they actually do a whole lot more than just lighting in games, and then how to actually implement them inside of GameMaker. So it's not just going to be head knowledge. We are going to tackle implementing a couple of shaders and how they work. What's also really cool is I'm going to show you how to look at the shaders that GameMaker already has in place through filters, find those for yourselves, and then you can take them and cannibalize them for your own projects. It's going to be really, really cool. But before we actually start with all of that, I just want to show you some of the things that you can do with shaders. So let me just make sure. Can you guys see my screen right now? Because I put up video for a second. I'm hearing some of you can't see it, but you can see my screen that I'm sharing. Excellent. So here is a project which I'm going to have linked to that has 18 examples, or like 15 to 16 examples of shaders that you can do. So this is really, really cool and available for you to download after this webinar. So this is a magnifying glass. A shader is a way to, we'll get to that. I just want to show you what they can do and then we'll dive into them. So here's like a really cool magnifying glass. And this project is so well built. It's amazing. You can actually go in and you can adjust all of the properties of each of these shaders and play with it and look at it. I just want to show you some examples just to give you an idea of things that you can do with shaders. So pretty much anything that goes on the screen, you can write a shader to change and manipulate both the pixels and how the image displays itself. So you can do simple manipulation, you can do crazy stuff to completely alter an image. You can do something like a Sin City effect where you highlight an individual color. And this can all be done in real time with virtually no hit to the game's performance. You can see here it actually has like the FPS is what's happening and everything. This is incredible stuff. You can also do animated things. So here is like an animated day-night cycle. Now you write the shader and then you have to write a little bit of GML to make it like run over time based on the data in your game. But this is just an example of something you can do like this. You've got one set of graphics, you apply a shader, and then it does all this extra work for you. It's just incredible. Like the world of shaders is so vast and so awesome that it's amazing that more people aren't into it. But I'm also going to talk about why people aren't into it, because it is kind of scary to get into. The last really cool one I wanted to show you was this right here. So you can, like this one specifically, I think just looks cool. You can change the time. So if you wanted to have like a really cool effect, you can do something like that. It's pretty neat. This is all done with shaders. You don't have to animate a sprite. You don't have to play any animation. You don't have to draw this, find it. It is all done dynamically, and you can completely control it through shaders. So this project will be available. All the art, everything is fairly well commented. Everything from the people is, they got licensed in the notes and everything, all the credits and all that stuff. So it's really, really cool. But what I want to jump into first is, what are shaders? Because a lot of people have no idea what they are. So if we open up the manual and we just search for shaders, GameMaker has a pretty good explanation of them, and then they also have a good introduction to them. But I want to take it a little bit deeper and talk about that. So if you look up shaders, you've got this right here. We actually want this link, this guide to using shaders. So let's talk about what a shader is and kind of how it works from a fundamental graphics level. So on your computer, you've got things that are pixels that are making up your screen. I think we're pretty familiar with pixels, especially if you do pixel art. But when it comes to game engine and rendering graphics on your screen, we're actually taking what we call like a quad, which is a kind of 4 points here makes up a cube or a rectangle or a square. But those are actually made up of triangles, which are then made up of vertices or verts. So what a shader does is it breaks down an image or a sprite or a texture into triangles, which in this case are two triangles which make a square. The reason that you use triangles is kind of complex, but essentially everything on your screen, even 3D graphics, are just triangles that are overlaid. The reason for that is when you put 3 dots on a plane, it makes a triangle, and that's the simplest form of geometry that you can use to actually start doing stuff with, because you can combine those into a quad and then into a cube, and then you can create 3 dimensions if you wanted to. That's beyond the scope of what we're talking about. But essentially, this is how it starts. You've got a couple triangles which make a quad. And this is what we would look at as like a vertex shader. We're going to look at both of these options here, but this is where it starts. So it takes it from a texture page, puts it into a quad, and then it goes through and it reads, and you can assign data to every single pixel inside of this. So I really like this example that they've got here because this is pretty much how this works. So we can go in and we can manipulate all of this. So we can change where something is actually at inside of the texture. We can move it around like swaying grass. We can figure out what a color is. We can grayscale it. We can invert it. We can do so many different things here with just doing this. And the reason that it works so well is because it runs on the graphics card. So most of the programming that you've done probably has been what we would call sequential programming, where things run one at a time. You use logic, you can use if statements, and it makes a lot of sense. Your computer figures it out, so on and so forth. And that's a very common form of programming, probably the most common in the world. But shaders aren't like that. Instead, shaders are actually going to run on your graphics card, and they are going to look at one thing, which is one pixel, and they are all going to run simultaneously. So they have no clue about what's next to it, what came before it, what's coming after. They don't care. They all run at the same time. And that's why shader, if you really want to get into shaders, it really helps to know what we would linear algebra, or just at least some math in there. So this whole guide, if you wanted to follow this, will take you through creating this rainbow shader across this character. And it can do this by using a bunch of math. Now, we are not going to jump into this. We're not even going to tackle something this complex because there's too much here already. But the idea here is that you don't use a bunch of if statements. Let's see if I can zoom in a little bit. Like this code right here to create this rainbow effect, it's not saying if the time is this and the pixel next to it is purple, change the next pixel to the next color that makes sense. Instead, it's doing things over time and speed, and it's using a lot of different math functions inside of here and a lot of multiplication. And you get something like this because the graphics card has to run all at the same time, which is why it's so fast. Your graphics card can run millions of computations a second, no problem. Your CPU, on the other hand, is a lot slower for things like AI and logic and doing things that actually take more thinking instead of just raw processing power to do simple things like put a pixel on a screen. So that's why shaders are a little more complicated, because it's a different form of programming and a different way of thinking. And the language we use is actually different as well. So all of that being said, let's actually jump into it a little bit. And here is just a simple project that I've got. So let me show you the setup because there's very little here if you want to follow along and do something on here. So I have a sprite. I have an object which has a create and a draw event. And right now the draw event just holds draw self. And then I have this object in my room. So before we actually jump into the shader code itself, I do want to show you that you've maybe used shaders already because of GameMaker's new filter and effect layer. This right here is shaders. And what's really cool is GameMaker actually opens it up for you. So if you know where to look, you can actually take their shaders. So in this case, if you go to your local drive under Program Data, GameMaker Studio, Cache, Runtimes, choose a runtime, bin, filters and effects. That's a very long file, but if you look it up, you can find where this goes. And this is actually the folder and project for every single one of the filters that they have right here. And you can open this up. So let's take a look at something like let's go to Grayscale. If we open up this project, it's actually a GameMaker project with the shader code inside that we can look at, read, copy, and put into our own code. So if you like one of the effects that GameMaker has, you can actually just open it up. So here's your project, here's the shader, and then this is the code for it. Like, that's it. You can take this out and apply it to your own, and you'll be good. It's really awesome. Now, they have a few things in here that we're going to talk about, but you can pass data into shaders to change it based on game data, and I'm going to show you how to do that. But this is really cool. And this gets down to the reason why I think shaders are so important. Even with this filters and effects layer, which they're going to continue to expand and do some really cool stuff with, like you can change the color and tint, and you can also apply these to individual layers, and you can control them through code. So there's a ton of things you can do. I think one of my favorite ones is like this distort right here. You can have like a Thanos snap over time, make them disappear. So you can control the amount over time, and you can apply this to all of the objects in your game, or just like a one or two of them if you wanted to. It's really cool. But when you boil it down, all of these effects are just shaders. That's all they are. They are shaders that have been written for you with a GUI attached to it, which is really useful and great, but that's all it is. Which means that if you can learn to understand shaders and you can learn how to write them and read them yourself, you are no longer limited to this scale, amount, offset, and distort texture. You can do whatever you want. You can make it look however you want. There's no limit to it. So even though we have this filters and effects layer, and it might seem redundant to learn how to write them, trust me when I say this list is so small compared to what you can do. And this list is also determined by what they have put in here. If you want something that isn't in here yet, you're out of luck unless you know how to write it yourself. So let's go ahead and jump into the basic syntax of shaders, and then we'll do a little bit of Q&A. So I'm going to close my room, and we'll go ahead, and I have a couple extra shaders, but we're going to delete those because we're going to make a new one. So we're going to create a new shader, and it opens it up, and I'm going to say shader. We'll just call this test. And I'm going to full screen this and press F12 to get rid of all those windows. Now, this opens up like a script. It's got code in it already, but it is different than anything we've used before for several different reasons, which we're going to dive into. First off, this is the Vertex Shader. So there are multiple kinds of shaders, but in GameMaker right now we have access to two. It is called the Vertex Shader and the Fragment Shader. These two work together, and each of them can do similar things, but each of them also has their own strengths. A vertex shader is actually putting your texture where it's supposed to be. So if we wanted to create something like a wavy grass effect, and we wanted to actually manipulate where the pixels are at in the vertex or in the texture, the vertex shader is where you do that. It's a little more complicated and uses like matrices and matrix math. We're not going to touch that today. Most shaders that you are going to encounter are actually fragment shaders. So there's two windows up here. We want to be on the fragment shader side. So we have not near as much, which is nice. So the first thing to know is that fragment shaders or the shaders in general, use a different syntax. So if we go back and look at this, because I want to make sure I say it correctly, shaders are, let's go back for a second. Here we go. So we are using GLSL ES 1.0 is the basic. So this is like a open shader language that is fairly common when you start getting into shaders. But the thing is that it's not GML anymore. None of these are GML. There are some functions that we have access to that you'll be familiar with. There's some logic like if and for and while loops and things like that. But for the most part, this is very, very different, and you've got to approach it differently. Because if you come into a shader and you want to use and you're thinking normally and you wanted to use a function like point direction, well, that doesn't exist. If you wanted to create a variable like health equals 1, well, this is just going to crash completely because you're not obeying the rules of this syntax. So let's go over what those rules are. First off, you have to specify data types. Now, you are familiar with data types even if you don't know it. In GameMaker, anytime you make a variable like name, and we set this equal to a string, this is what's called a string. It holds characters, and that's what it does. But the thing is, we didn't tell that this variable was going to be a string. GameMaker's just like, hey, you made a variable, you happened to put some characters in it, cool, it is now a string. But at any time later in our game, we could easily go, hey, my name is now 100 because I like numbers. GameMaker's like, cool, no problem. In a lot of other coding languages, which are stricter, this is not allowed in the slightest. You have to say this is going to be a string. You have to set it to a string, and then you can never do anything with it that is not string related unless you do something called casting, which, again, beyond the scope of what we're talking about. But all that to say is you actually have to say what kind of data type this is. So the most common data type you're going to be working with are floats, which is a floating point number. So let's say we had health in here. This is a floating point number. It has a decimal and then a value after it. So this can go pretty big depending on the size of the float that you want. But in writing shader language, you are pretty much always using floats and decimals. So unless you actually say it's an integer, which is actually really uncommon, you need to use a dot and something after it. Otherwise, the game is not going to compile. So if I took out this dot and I just said it was a 1, and we press F5 to try to compile this, you're going to get an error. And the other thing that makes shaders really difficult is that they're not useful errors. So it's kind of hard to see because it's small, but all this says is that Fragment Shader, shade test at line 8, and it has an equal sign. And it says string not found at line 1. And now we're getting all sorts of different errors. So it says there's an error at line 8. There's nothing on line 8. The issue is this is not an actual floating point number. If I do that and I compile, now we're good. So when you get into, I'm going to go in also and take that effect layer out. So when you start getting into shaders, they're intimidating because they have much stricter syntax. You have to obey, you have to follow their rules. And if you don't, you're going to get a list of errors a mile long that are completely useless to you, even when you start becoming familiar with writing shaders. So you have to give it a data type. You must use decimals when pretty much everywhere that you're going to be using them. And you have to use a semicolon. Same thing here. If we leave out a semicolon, like some of you might do when you're coding because GameMaker doesn't care, well, now we have a new error, but this one says it's at line 10, and it doesn't even say what the error is. So, data type, you have to use a decimal, you have to have a semicolon. Float is probably the most common, but you're also going to access things like vec2, vec3, and vec4. Vec stands for vector. A vector just means it has, kind of like an array, it has multiple properties. So if I say vec2, you can imagine that it's got something like this. Now this won't work because we have to do it a different way, and we have to actually give it, I don't know, we have to give it a name. This variable here, date, has two values. Basically, like this. Date and then date 1. Now, we don't actually access it like this. I'm just showing this to visually represent it for you. So we've got a variable with 2 values that looks like this. But in shader language, if we wanted to access that, there are a couple different ways, but we would essentially be using R, G, B, and A. So depending on what kind of data type we've got here, R is the first one. So R in this case would be 2, G would be 3, and then in this specific case, we wouldn't actually have any more. So we would just say something like date.r. And if we wanted the second one, we could use date.r, yeah, G. So if you're familiar with RGBA, it's red, green, blue, and alpha. And if we look up here, we have something called color. And this is actually holding the red, green, blue, and alpha of every single pixel that it finds inside of our shader. So we've got vectors, floats, and different ways to access them. So if we wanted to actually create this vec2, this won't work. We have to say vec2, and then we're initializing, and then we can actually pass these values in. So this, if we run, would actually compile. No problem. And this might look kind of foreign to you, and I get that. This is a different way of coding. It's not GML, and it's kind of confusing. But you have to use their data types, and this is how you do it. So same thing goes here. So if we had a vec3, you'd have to initialize it like this, but you'd pass in 3 values instead of just 2. The numbers here tell you how many. And for something like color, you're using RGBA, and you access those in that order. Now, this is a lot of heady information. We haven't actually started doing anything yet, but I just need to get you familiar with it, because if you don't understand how to write it, as soon as you go to do anything, it won't work. It'll just get a compile time error. So let's stop right here and let's jump over to the Q&A, and let's see if there's any questions that is going on. So I'll go through the questions that we've got. If you have any questions, just post them right now, put a question mark at the end, and I'll be able to see them. So let me make sure that we've got here. So first question comes from John. Is each pixel in the fragment shader assigned to a core thread in the GPU for manipulation? So you're talking about multi-threading coding, and as far as I'm aware, well, I do not know how to assign a specific pixel to a core or thread in the GPU. I will say that it is multi-threaded because it's all running at the same time, but I'll let Gurpreet do some research and see if he can answer that more specifically. I know in multi-threading in some lower level languages, you can actually assign a specific task to a core and then see when it's done. In this case, we're just telling it to go off, and the graphics card takes it and it works in whatever order that it goes through. Fahid asks, what is the default code? It didn't say vec2, it had something else behind it. So you're talking like back, so there's 2 shaders. We've got the Vertex Shader and the Fragment. Over here, this is a qualifier called varying, which means that it's being passed from the Vertex Shader over to the Fragment Shader because these are different things. We'll also come across something called uniform, which is how we pass data from our game into the shader. So varying and attribute, these are attributes or qualifiers for these. And varying specifically means it's being shared between the 2 shaders. Cody says, will we go over how to apply the shaders to individual objects, layers, or everything? Yes, I'm going to show you how to actually apply a shader. And what's really cool is when you take a shader, you choose where to apply it. So you can put it on an individual sprite. You could apply it to the application surface. you can apply it to whatever you want. So the shaders you write can go anywhere. They can also go on vertex buffers, which is a whole different webinar. But yeah, there's a lot you can do there. Gershon asks, does this work in JavaScript? So what I will say is shaders, there's different kinds, but the most popular one is called OpenGL. It's a way that graphics card makers allow programmers to interface with it. And it's a standard language. And you can use OpenGL syntax in almost anywhere that uses a graphics card. So if you're working in JavaScript and you want to write some shaders for something, yes, you can absolutely do that. If you go out to, I think it's Shader Toy, and look that up, they have some incredible shaders and effects that are just running in the web browser, no problem, because it's open and it's anyone can do it. Michael asks, is it true that loops can't be made of dynamic uniform parameters? They need to have a fixed length / iterations. Wow, Michael, that is a very interesting question, and one that goes beyond the scope of my knowledge here. What I will say is I know you can do while loops and for loops. I have not seen anything that says you have to have a fixed length or use iterations, specifically coming from uniform parameters. But because it's a graphics card and it's a shader, I imagine you, well, no, you probably can. I don't know if there's a limit, so I'm going to pass that off to Gurpreet and Kinga as well. Is there a limit on how much of a loop you can do on a uniform that you pass in? That's a very good question. Bobby asks, what is the difference between Vec1, Vec2, and how do the two vectors interact visually? So I'm going to be showing you that here once we actually apply a shader to our game. We're going to be going through, I'm going to show you how to do a simple grayscale and how to actually do some math inside of that. But the answer would be a Vec1 is actually just a float because it's a single number. A Vec2 then allows you can do what we would call matrix multiplication. So if you've ever done that before, you've basically got a column or a row, depending on how you want to visualize it, and you would multiply those together. So the order you multiply them in is important, because if you multiply the first row by the second row and then change columns, it does give you different results. But yeah, I'm going to show you that visually in just a little bit, so we'll get to that. Emma asks, are shaders like the ones you showed us in the IDE going to be much on integrated graphics? So that is a really good question. So if you're targeting an integrated graphics card like a laptop or a phone, from my understanding, those are actually still incredibly powerful. Like even if you went back 5-6 years, you would probably be able to run any of the shaders that are running now totally fine. And that's because a graphics card is just great at doing brute force tasks. They can do the same thing millions of times a second, and they're really, really fast at it. So if you write shaders for integrated graphics or you're running them on integrated graphics, you'll be totally fine. Franco asks, are there different float precisions in GLSL? Yes, there are. There are 3 different precisions that you can jump into. I don't know the default precision that is set, but you can specify low, medium, and high, which gets you to huge, huge numbers. And yeah, that's really all I'll say about that. W asks, how do we use Sampler 2D to pass in texture info? Sampler 2D is something I am not familiar with. Texture 2D is something here. Sampler 2D. I have not used this yet, so I'm going to let Gupri or Kinga answer that for you. I am not yet familiar with Sampler 2D and exactly how that works. Wilden asks, is there any difference between using RGBA or XYZW? Is there any tip on when to use one of those? So the standard is when you're using colors, you use RGBA. When you're using coordinates, you use X, Y, Z, and W. And there's even another one, but the thing is, I didn't want to mention it because technically they're actually doing the exact same thing. It just makes reading it significantly easier when you use the correct ones. Like if you're trying to move your sprite or your texture around in the world, but you're using RGBA and you're reading it, you're like, wait, why am I affecting the color of this when I want it to move? They're doing the same thing. They're the same constants. They just have different names. And I just didn't want to bring that up, which is why I didn't. But use the one that you're using for the one you're using. RGBA for colors, XYZW for coordinates. Now, there's still a lot of questions here, and I don't think I'm going to be able to hit them all. So I'm going to go through, read them really quickly, and see if there's anything that we need to do. It looks like they're answering some of those themselves, which is awesome. One important question is, Michael asks, if you initialize a variable with vec2, 3, or 4, do the values have to be floats? And yes, there is such a thing as ivec, which would be an integer vector. Otherwise, yes, assume that everything is a float. Otherwise, you will have issues. Okay, Michael asks, can the main run for each pixel? So can I forward the result? From my understanding, this is not how it works. It is not sequential, so it doesn't look at what happens to the next one. It all runs simultaneously. That's the whole point of a shader and using a graphics card, is that it runs so fast. So you can't take the information from one and go to the next with it. It's not like an if statement, or it's not like it's running in line through that. So that would not work. So I'm going to go ahead and end the Q&A there, and I'm going to jump into how to actually use these shaders in GameMaker, because I think that is what we all came here for. So I'm going to close the Q&A for now. We'll hit that back up. I'll put my screen back up here. And let's go ahead and look at how to do this. So we've created a shader already, right there, shd_test. Now let's go into our object, and in the draw event is where it's going to take place. So drawing, anytime you're going to draw something like yourself, the application surface, another sprite, this is where you would actually apply the shader. And using a shader in GML language is actually pretty easy. The first function is called shader_set. And then you pass in the shader. In this case, shade test. So this is how you run a shader. If I press F5 right now, then we're good. This is the shader that we have created. Right now, there is nothing on there because we have created the most basic shader that you can, which is doing nothing. All it's taking is what was there and putting it onto the screen. But we can start manipulating this, which is awesome. So first thing to note is this line right here. This GL frag color is what is eventually drawn to the screen. And this line is it's taking the VV color, which is a vector 4, and it's multiplying it by texture 2D. So what this does is it gets the correct pixel for the correct spot, and then it puts it there. So what I'm going to do is actually say, create our own variable here. Well, actually, we're going to take this. We're going to say vec4. So this is going to have 4 different parts to it. We're going to call this my color. And we're going to set it equal to this whole section right here. So I'm going to cut that, paste it. So what I'm doing right now is I am copying the original pixel. This is what the original pixel is, just as it would be displayed on the screen. If I come down a little bit and I say display this now, we're going to have the exact same thing. Nothing is going to happen. So voila. But now we have this in-between section where we can do something. Let's say we wanted to just take everything here and say my color, and we want every single pixel's R value, which is the red value. And just in case you're not familiar with like RGBA, let me bring up this sprite really quick as a visual representation. So like if I wanted a specific color, I can actually use this dropper. I can click on this and I can double click. Here's your red, green, blue, and alpha. Alpha is for transparency. Red, green, blue determines how much of one color goes in one spot, and then you combine those all together, and that's where you have a color. So in our shader here, if I wanted to turn every single red into full red, because one thing we haven't really discussed yet is how shaders normalize colors. Normally you go from 0 to 255, but in shader language, it's from 0 to 1. So if I turn every single pixels red into 1, there we go. Now it's very, very red. And you can do the same thing on G. So I turn it green. This is just super simple coloration. It's not even very pretty or very useful, but it does show you how to start actually manipulating this shader. So you have RG, B, and A that you can affect. So if you wanted to make it like invisible, we could turn the alpha all the way down to 0, and now there's nothing there. So we have the color of the original pixel in my color, and then we can access it over and over. So we have simple color manipulation. Now, something that we can do is also pass in information from GML. We do that with what's called a uniform. So varying up here is passing it from this shader to this shader. Uniform allows us to pass it from GameMaker into the shader language. So we need to specify the type that it is. So we have a uniform, and then we say float, and we're just going to put mouse. What's pretty cool is you can just create it like this. You don't have to set it or give it any value just yet, because we're actually going to pass in that value. So here's the mouse. And what I'm going to do is I'm going to set my color dot R, so we'll just play with R, red again, equal to mouse. So this is going to be the mouse value for what we're doing right here. So I'm going to go ahead and go back to our workspace and open up our object. So our object night here, we have two things we need to do. The first one is we need to get access to that uniform, and there is a function for that. It's called shader get uniform. And we call this in the create event because we only ever need to do this one time. So we need to get the shader. So first we pass in where it's coming from, which is shader test. And then we need the uniform name. Now, GameMaker doesn't communicate with shaders like an object to another object. You can't just access a variable in there. GameMaker has no idea what's in a shader or what isn't. So we have to take this. I'm going to go ahead and copy it, because we have to say in quotes as a string, this is the uniform variable I want to access. So this is the shader, this is what it's called, and then we need to say, we'll just call it mouse. So this returns the handle that we are going to use to then pass information to the shader. So mouse equals shader get uniform from shader, and this is the name of it. If you type this wrong, you're going to have issues, so make sure you copy and paste it if it's more complicated than something like this. Now we have access to it. Let's go to the draw event. And before we draw what we want to pass in uniform info. The way we do that is called shader set uniform, and then we have to tell it what kind. So there's uniform F, I, and matrix, and then array forms of each of those. In this case, we have called this a float. Now, vectors are just floats with multiple values, and so if you were to create a vector variable, you would use the same one because you can actually pass in multiple values here. So I want to pass in a value for mouse, and then you can see it has a value. And you can actually do as many as you want. In this case, our variable is just one value. It's just one float. And we're going to pass in our mouse x divided by room width. This is just a simple division, simple math statement that's just going to give us a value from 0 to 1 because that's what colors are in GameMaker. So with this, we are now altering the effect of the red pixels in our sprite based on our mouse moving. So you can see that as I go from right to left, it gets less and less red because it takes it all out. As it goes left to right, it increases red. So we can pass in any information we want right here, such as time, health, uh, playtime, characters, anything you want. It's got to be in floats, integers, or vectors, but we can pass that information in, which means that we could make this thing flash red over and over again if we wanted to. We can make it change based on the time of day in our game for a day-night cycle. You can do so much here with uniforms. You create it, you save it, and then you set it. Now, I want to show you at least one semi-useful piece of shader here. And it's going to come from, not there. I lost it. Let me bring it back up. So it's gmshaders.com. Here it is. This is a great little website written by Zor, Xor. He's on Twitter. He's a shader wizard, is what we call him. And he's got some examples inside of here of how to use some shaders, but also how they work. So this is great if you want to do a deeper dive into shaders. What I want to do right now is jump over to some of his examples. So he's got something here about inverting colors, which is kind of cool. But then he also has like a grayscale option here. Now, if you want to throw one of these inside of here, you absolutely can. You've got shaders for changing lots of different colors. These are just super simple things, and you can use them. What I want to do is implement a grayscale shader. So his example here is taking your texture that you've got, and it's multiplying by a specific amount. So what it's actually doing is setting it up so it's just all the way around. It's changing the color to a gray, but it's doing it based on how luminescent that color was before. Because when we look at grays, if we like colorblind or we black and white video, colors are different levels of gray based on how bright or dark they are. And that's what this is actually doing. So when I look at this, I now remember that we want to do something like this, but the issue is he's using a text here, and I'm not actually sure exactly where he gets this text from. Like reading through this, I couldn't find it. So this is a really great example of what we want to do, but the other one is Dave Tech. So Dave Tech, this is the other place where you can learn about some shaders. He's got some shaders on grayscaling here, which is what I want to grab for you. So if you are going through and you're finding a shader or you're asking questions about it, it might be really confusing to actually implement it, because what's going to happen is someone's going to be like, hey, how do I do X, Y, or Z with a shader? And they're going to be like, hey, here's the code. Go ahead and use it. But you have to understand that it's not just as simple as copying and pasting that code. First off, you have to know where it goes. So there's the Vertex Shader and the Fragment Shader. Which one are you talking about? Are you using uniforms and all of those other things? And then how do you actually apply the shader if you've never used it before? You don't know. So here's an example of finding a shader and just throwing it in your game and how to do that. So he's got an article on how to grayscale things correctly. He's got several different examples here, and then he's got some code examples. So this is the code he's got, but without context, it can be really confusing on where to even start. So what I'm going to do is take this code, and I'm going to copy it. Because we are altering pixels, it's going to be a fragment shader. If we were doing something with actually changing where the pixels are being drawn at, that's going to be a vertex shader most likely. But what we're going to do is go into the fragment shader, and I'm going to go ahead and comment this section out. And then I'm going to paste his code inside of here and tab this to be correct. So first thing that he does is create a vector 4. Now we've already talked about these. It has 4 values. It's a color because he's named it this color, and he's just copying it from the same thing that we did originally. This gets the color correctly of every single pixel that's there on your sprite. And then he's creating a float called new color, and he's doing dot multiplication. So this is how you can multiply many things against many other things. So he's grabbing the 3 values, the RGB values of this color, and he's multiplying it by this vector 3. So this is how you can take that math, multiply one column against another, and then it saves it as one number right here. So what it's doing is it's taking all 3 values, multiplying them, and getting the correct grayscale on that. And then he's setting it right here. So you're setting it as a vector 4 because that's what GL frag color is. So like back over here, like the original setting of GL frag color was this line, which is a vector 4. So anytime you set GL frag color, in the end, it's got to be a vector 4. In this case, it's new color, which is gray, new color, which is the gray you got, and the new color. So whatever that was before, that's what it is now. It's now a gray. And then he's setting the transparency of every single one of those pixels to 1. Now, this is going to cause an issue, but I'm going to show you why and how to fix that. So here is our grayscale. You can see the sprite itself is gray and it looks really, really good, but we have this weird black box around it. And that's because that black box is actually from the texture page that this sprite is stored on. So that's no good, but what we can do is instead of setting every single pixel to a transparency of 1, which is what's the problem is because it's taking transparent pixels in our sprite. So all in this whole sprite, all of this is transparent around it. But that shader we just created says take every single pixel and set it to 1, whereas before it was 0, all the ones around it are now 1. That's the problem that we've got. So we don't want to just blast a full 1 to all of these. Instead, let's return it to what it was originally, which is this color and its original alpha. And if we run that, now it gets rid of that black box. So that's a simple grayscale shader, and you can affect this with uniforms. You can change up these values over here. And this is just the simplest way to use shaders in GameMaker. Like I said at the beginning, this really isn't even scratching the surface. This is just equipping you with the tools to get in and start diving in. There's there's so much here, and as someone in the chat is already pointing out, they're encountering errors that make no sense to them. And the problem is that it's hard because if you make one tiny mistake, like leaving out this semicolon, you get a string of errors that are going to make no sense to you. If you make any mistake anywhere, you're going to have a problem. But dive in, take your time, ask questions, and just realize that this is learning an entirely new coding language. It's not GML. Like that's probably my biggest mistake when I started was, oh, shaders are cool. They're just complex GML, but it isn't. It's a totally new syntax. You have to take the time to actually learn how it works, and you have to take the time to learn why it doesn't work in certain situations. Okay, let's go back and do some Q&A because I'm guessing there are some people that really want to know some more stuff. So let's jump over to Q&A. And if you have any questions, let's go ahead and jump into those. So someone is working on debugging their code and they ask, why is their code wrong? I don't know. I'm trying to find it, but I don't know if I can do any debugging of your code right here. What I will tell you is that it's hard. It takes a lot of time and it can be very frustrating. So copy as best you can, download finished projects, compare those to yours if you're having any issues or struggling like that. It helps a lot. So, but let's go through and ask and look at some of these questions right here. So, first question, that's not a question at all. uh, okay. Cliff asks, can I do a tutorial on how to broadcast a webinar? I don't think you want me doing a tutorial on how to broadcast a webinar because I have a big problem with it. But sure, I think that's a great idea. Fahid asks, how do I add fragment shader? So that's when you create a shader, by default, or every time you create a shader, you create a vertex shader and a fragment shader. These two things are intrinsically linked. You are creating a fragment shader when you make one. If you want to use just a fragment shader, all you do is just leave the vertex shader alone. It's just going to put things where they belong. And then if you want to use just fragment shader logic, go into the fragment shader and use it there. That's how that works. You can't just use one. You're always using both. What are all the primitive values you can use in a shader? Float, int, vec, etc. So that's a really good question. And if we go to the gmshaders.com, he's actually got this entire thing listed out. So essentially you can use floats, integers, booleans, and then vectors. So vec 2, 3, and 4, and you can create integer vectors as you want. Then you can also create matrices. So matrix 2, 3, and then those are the data types that you can use. And then you also have things like you can create structs if you want. You can create arrays as well. And then you have, someone did ask earlier about precision qualifiers. So you can do precision, high, and low. Those are things that you can also change. And then you also have things like constants as well that are inside of there. Next question comes from Cody. What exactly does the texture 2D function do or return, and why multiply it with color? So texture 2D is mapping out the text that it get the pixels that it gets from the texture page. So not to spend too much time on it because it's an in-depth question. When you go to tools and texture groups, you can actually look at the textures from here, and GameMaker creates a texture page, and what the shader has to do is figure out where exactly that is in the texture page. So these ones here, like, let me see if I can bring this up to show you a really good example, because this is a great question. So a texture page can have a lot of different assets inside of it. It's not just one sprite at a time. So if I load up that original project that I showed you, and by the way, if you're looking for that original project that I showed you, it is, we'll see if we can have a link to it in the video on demand version, but it's also from Gaming Reverend's Dev Corner. So he's got a really fantastic series going through this. And in the description, he has the project available to download with the entire thing, which is just incredible. So look up his stuff and you can find that project right here. But if we go to Game Options, Windows, and we go to Images, or we go to Graphics, we can actually preview a texture page. Now, this texture page is pretty large, and depending on how many sprites you have in your game, it's going to take a while for it to bring up. But here is an example texture page. So what we're doing in the shader is we have to actually figure out exactly what we're grabbing. So if we want to texture this sign, we have to know that it's around here, and then where exactly it's at in there. And so that's what it's doing, is it's mapping the color that it gets from here onto the texture it's actually pulling from that texture page. If I am understanding that correctly, Goopreet can probably correct me if that's wrong, but that's why you have to multiply this. If you don't multiply this at all, then it's just going to change your entire thing. So let's say if we just set GL frag color to V color and we didn't multiply this at all, what it's going to do is just set it to just one single box. So it doesn't know which one is which. It doesn't know what's happening. It just sets every single pixel inside of that to the color that it has. So that's why you've got to have that. So there's a lot of other questions here. I don't know if we're going to have time to go through it because we had a little bit of a tech difficulty there. But let me see if I can look over any ones that I think would be really, really useful. So Tevin asks, can shaders be triggered by an event? Shaders are just a way to change what's being drawn on the screen. So in GML, you control when they happen. So yes, you can absolutely trigger by an event. If you wanted to have a collision event that when it's colliding, you then draw the shader, absolutely. The shader itself doesn't know, it can't really know, and it doesn't care about what's happening inside of your game. We call it blind because it's just doing what it's told. It has no real logic beyond do this here this many times, and that's it. So if you want to trigger a shader, that's all going to be in GML. So we've also got Jens asks, any good books on the topic? There are some really good books on the topic. There are also some really great online communities and playgrounds out there. So one of the really, really good ones that I have found. So if we look up Shader Toy, this is not exactly for GameMaker specifically. There is a GameMaker book out there. I don't know how relevant it is. It might be kind of old, although shaders language really hasn't changed. So if you find a GameMaker shader book, you should be totally fine. This is a website that you can just look around and experience shaders. It is not GameMaker shaders specifically, so you can't just take these and plug them into your game, but they give you an idea about the things that you can kind of do with shaders. It's really, really cool. So any book you find should be pretty relevant to the case because shader language has not changed in quite a while. And I see some other very specific questions there, but I think we're going to end it right here because you guys have been fabulous and I really appreciate it. So thank you very much for your time. Thank you very much for attending. It's been really, really awesome. Let me see if I can bring myself back here. Okay. So thank you guys so much. You've been really awesome and very patient with those technical difficulties. Although I will say you guys were probably the funniest during that time. That was fantastic. So thank you for joining. This will be available, I think, unless it was so butchered because of those technical difficulties, but it should be available on YouTube here in the next week or two. And if you have any more questions, what we've done in the past is we've had some of our experts go through and then do a follow-up video on those questions. So if you asked a question and I didn't get to it, then definitely take the time to look that up because you might just see the answer coming out from Yo-Yo answering those questions in a really informative video. But that's all I've got for you today. Thank you so much for joining me. Thank you for bearing with me through this. I had a great time, and I hope you learned a little bit about shaders and to be able to get started with it, even though it can be a little intimidating. Until next time, keep making, keep learning, and I'll talk to you later.